Okay, this is the key for the Chapter 7 test. I'm going through the vocabulary real quick. This is B, D, A, C, G, and F. Explain the angle-angle similarity postulate. You need to say that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. And what similar means is same shape, different sizes. And then if they are similar, all the angles are congruent, and then the sides are all going to be proportional to one another. But the similarity postulate says two triangles are similar if two angles of one triangle are congruent to two angles of another triangle. Here, number 8, the ratio of two complementary angles is 58, or sorry, 5 to 8. Find both angle measurements. What this means is that these two angle measurements are they've been reduced. Okay, we're comparing the two angle measurements. They've been reduced to 5 and 8. We need to find out what amount they've been reduced by. So to find out what amount they've been reduced by, if we think about reduction of two numbers, we do that through division. So I'm going to undo that division and use multiplication. So I'm going to take 5 and 8, and we need to multiply. We're going to make those bigger by some factor, and they've both been reduced by the same thing, so we want to enlarge them both by the same thing. So I'll multiply both of them by x because we don't know what that same thing is. So we call it x. Okay. Now these two angles are going to be complementary. So I'm going to add them together instead of equal to 90. That's what complementary means. Now if you look at this, eventually, depending on what x is, this number is going to grow. 5x will grow. 8x will grow. At some point, they will grow at the same rate, and eventually their total will be 90. Okay, well, we got to see what they're growing by. So this is going to be 13x is equal to 90. When I solve for x, x ends up being about 6.92. Okay, so that's what both of these angle measurements have been reduced by. Okay, so that we want to know then what were the original angle measurements. Well, if I take 6.92 and multiply it by 5, that will give me one angle, which ends up being 34.6. And if I take 6.92 and multiply it by 8, that's going to give me about 55.4. Okay, and again, those are rounded, but they total 90. So basically, these were the two original angles that were complementary. They've both been reduced. If I divide that by 6.92 and I divide that by 6.92, I get 5 to 8. We're going to do the same thing down here in this number 9, except for now, the sides 3, 4, and 5 of a triangle, and their perimeter is 72. So perimeter is just adding these things together. Well, if I just left them that way, that's not obviously going to equal 72. 3, 4, and 5 have all been reduced by something. What have they been reduced by? We don't know. Okay? So when I enlarge these, I don't know what they're going to be enlarged by, so we call it x. So when all of these are enlarged by the same x value, eventually, depending on what x is, they will total 72. So I got to find that x. So what I get here is 12x is equal to 72. X ends up being 6. Well, if x is 6, then this side here would have been 18. The 4x side would have been 24, and the 5x side would have been 30. Think about reducing these three values. If you wrote this as an extended ratio, they are reduced by 6, and then when you divide all of them by 6, you get 3, 4, 5. So 6 was the number that 3, 4, and 5 get enlarged by to give me 18, 24, and 30, and those three lengths of my triangle add up to 72. Question number 10 here. Basically what they've done is they've taken the numerator and added the denominator to it to get this part, and then they wrote it over the denominator. So I'm going to do the same pattern. 2 plus 3, and then write it over 3. If you change it to 5/3, that's fine. Over here, what they've done is they've taken, to get this first ratio, they've taken this numerator divided by that numerator. Okay, so I'm going to follow the same pattern with the things that I haven't used yet. So they wrote j over g, so I'm going to write 8. I'm going to go from the denominator to that denominator, so 8 over h. Think about these things. If these are our properties of proportions, if I cross multiply here, I should get 8g equals hj. Well, over here, do I still get 8g is equal to hj? So I know that because I alter this proportion to get this, my cross product should still be equal. Okay. Um, Looking at number 11, cross products again. I want to cross multiply. When I cross multiply, I'm going to get 3x squared minus 3x minus 2x plus 2. That's what that cross product is. And that's going to equal then 10x plus 20, which is that cross product. I've got an x squared here, so what I want to do is end up solving this, or setting this equal to 0. So I'm going to move everything over to the left-hand side. So this is going to be 3x squared minus 15x minus 18 is equal to 0. Okay, that's basically combining those two at the same time that I moved the 10x over. When I factor, I always want to make that term, that a term, a 1. So if I can, I want to divide everything by that and see that I get whole numbers everywhere. So I divide 3x squared by 3, and I get x squared. Negative 15 divided by 3, and I get negative 5. And then negative 18 divided by 3, and I get negative 6. So now I can actually factor that instead of this. That right there would have been hard to factor, but this is easy to factor. Two numbers that multiply together give me negative 6, and add up to give me negative 5. Okay, so they've got to be, what, negative 6 and positive 1. So then I set x minus 6 equal to 0, x plus 1 equal to 0, and this one's going to say x ends up being 6, and this one says x ends up being negative 1. Those actually are both my answers. Okay, a lot of people are going to, we get in the habit of crossing out the negatives because we talk about distance a lot, but this one has nothing to do with distance. The question has nothing to do with distance. The only thing I would want to check is to make sure that when I plug in either of those values into either there or into there, that I don't get 0 in the denominator, because we can't divide by 0. So, negative 1 plus 2 is fine. That's not 0. And 3 times negative 1 minus 2 is not 0, so we're okay with negative 1. Same thing with 6. 6 plus 2 is 8. That's not 0. And then 3 times 8 minus 2, that's not 0 either. If I found x to be negative 2, then we'd have a problem right here. I get negative 2 plus 2, which is 0, and then you can't divide by 0, so I cross that answer out. But in this case, I do not end up dividing by 0. In this question number 12, what I suggest doing is redrawing these two pictures so that they are not overlapping. That'd be my small figure. There's the large one. In the small one, okay, this segment here is 10. That's x, that's y, and that's z. Over here, this distance across the bottom is actually going to be that distance. So that's 10 plus 14, so that's 24. Hopefully there you recognize your scale factor, 10 to 24. This side length over here is 12, this one's 16, and this one is 15. I'm going to say 10 is to 24, as, solve for x first. So x is to 15. See, if I write them this way, I can say, that corresponds to that, bottom to bottom, and now left side to left side. Okay. If I cross multiply, I'm going to leave that work up to you, but x ends up being 6.25. Now, if I wanted to find y, okay, well, I'm still going to use the scale factor of 10 to 24. So 10 goes to 24. Okay. Now over here, it's going to be y goes to, well, y corresponds up here to 16. Cross multiply there. I'll leave that up to you again, and I get y to be 6 2/3. Okay. Remember, 10 to 24. This is the little figure. This is the big figure. So over here, this y, that's going to come from the little figure, and this 16 has to come from the big one. Okay. I want to keep my numerators coming from the same shape. Okay. Same thing with my denominators. Make sure they come from the same shape. And to find a z, I'm going to go 10 to 24 again, scale factor. If I want to find z, okay, that came from the little shape, so did 10, so they get both in the numerators. And then z is going to correspond to 12. And when I cross multiply there, leave that up to you again, z ends up being 5. Going on to The next page, same idea. It's basically almost the same question. Um, Redraw the pictures though. If I redraw this picture, there's the small BCDA. So BCDA. This distance here is x. This one is x minus 2. I'm going to redraw the big picture, the big rectangle. So that's E, F, G, and then A. So if I look at A to E, well, that's the sum of that distance and that distance. Okay? Well, that's x minus 2 plus 5, which is going to be x plus 3. And the bottom is going to be x plus 7.5. Okay? Now, if I look at these and compare them like the last question had a visible scale factor. Here, we don't have a visible scale factor, but they're all in the same variable. Okay, they're all x. So I want to say x minus 2, that side right there should correspond to this side, plus 3. And then this bottom, which is x, should correspond to this bottom over here, which is x plus 7.5. Now, when you cross multiply, you're going to get x squared plus 3x going right there. And then the other side, or the other product, is going to be x squared minus 2x. So x squared, x times x, minus 2x. And then, what, plus 7.5x minus 15. I'm going to go ahead and combine all my like terms and move everything over to one side, or all my x's over to one side. And I recognize that the x squared and x squared, they're going to cancel each other out when I subtract x squared. I'll add a 2x over here, so it gives me 5. So eventually I have 5x is equal to 7.5x minus 15. I still got to move that 7.5x over, so I'll get negative 2.5x over here is equal to negative 15. Oh, 15. And then I'll now divide both sides by negative 2.5 and get x to be 6. So x is 6. Now AB was this distance right here. So that's x was 6 minus 2 is 4. And then AG is this distance right here. So x, which is 6, plus 7.5, 13.5. Number 14, they ask you identify the similar triangles and make a similarity statement. Okay, also find x. Okay, well, I know that these two lines are parallel, so that's going to say that that angle there is congruent to that angle there. And I also know that these angles are vertical. Okay, so what I'm going to do is I'm going to redraw these two triangles. Okay, so this is B, A, C. And we know that this is x plus 3, and this distance here is 1. Okay, that's got 1 hash mark in it, and that angle has 2 hash marks in it. So that angle right there, that triangle, call that triangle 1, is the same as that triangle there, and I didn't change the orientation of it. I'm going to change the orientation of the second one, though, so that it matches up exactly with this first one. So I'm going to redraw this triangle 2 here as the red one. Okay, well, I want to match it up so it looks like ABC, so that's got to be 1 hash mark, and that has to be 2 hash marks. Well, if I rotate and flip this one, the 1 hash mark, well, that's got to be E, so that point there is E. 2 hash marks has to be C, and now the one that doesn't have any hash marks is D. And going back through here, C to D, that was 6. E to C is 11x minus 2. And now hopefully you recognize what can correspond. I know that this side here should correspond to that side. So I'm going to write x plus 3 corresponds to 11x minus 2. And now I can say that that side there should correspond to that side. So I'll say 1 to 6. So equal to 1 over 6. Cross multiply, I get 6x plus 18 is equal to 11x minus 2. I'll add, well, let's go ahead. Yeah, I'll subtract 6x from both sides. So I get 5x here. Add 2 to both sides, I get 20. So x ends up being 4. So that's what we're looking for there. Okay. Now another reason why I redrew these triangles so that they look like this now, because they're in the same orientation, I've got that angle matches up with that angle, and this angle here matches up with that angle there. So I know that these third angles, A and D, are matching up. So now when I name it A, B, C, I go from A to B to C. I can follow the same pattern down here. I go from D to E to C. Now it says, what theorem or postulate states the above triangles are similar? Well, we had 2 angles here congruent to 2 angles there. If you remember back to question number, I think it was 7 or 8, asked you angle-angle similarity statement or postulate, what it said, and that's what it said. 2 angles of one triangle congruent to 2 angles of another triangle, then 2 triangles are similar. Moving onward. If we look at number 15, 15 is really the same concept. I'm going to redraw these 2 triangles so that they are in the same orientation. Okay, so this one is A, B, D. So that's triangle 1, A, B, D. Okay, there's my right angle, and there's the other angle that should be congruent. Okay, if I look at the bigger triangle, well, the right angles need to both match up. So if that's B, then this has to be E, because that's the right angle in this second triangle. And if this top angle had 1 hash mark in it, this top angle better have 1 hash mark in it. So that's got to be F, and this would be C. Now I know AB is 3, F to E is 8, and now if I look at this stuff over here, BD is x minus 1, and CE is x plus 2. Now I can say, 3 compares to 8 as x minus 1 compares to x plus 2. Cross multiply, I get 3x plus 6 is equal to 8x minus 8. Go ahead and solve. You get x to be 14 over 5, or if you wrote that as 2.8, I accepted that too. Okay, so x is 14 fifths, or 2.8. Now going back and finding what BD is, well, 2.8 minus 1 is 1.8. Okay, and then EC is 2.8 plus 2, so it's going to be 4.8. Now if I've drawn these correctly, A to B to D, going from that to that to that, I should be able to follow the same pattern, F to E to C. So F, E, C. And again, the reason here, we're at an angle congruent to an angle, and then another angle congruent to another angle, so that's the angle-angle similarity. I actually ended up giving everybody points for number 16 because I feel that I poorly wrote the question in terms of labeling these. We talked in class that we should, if the triangles are similar, the quickest thing to do is compare small side to small side, largest side to largest side, middle side to middle side. And then if they all work out to be the same proportion, then yes, they are similar. We don't want to compare the largest side to the smallest side, because if they're similar, the largest side will never end up being the small side in another triangle. Okay, if that confuses you, come see me and I'll explain that with some pictures a little bit better. But the way I name these, and I talk to you in class, they will never name them with A and A prime, and B prime, and C prime, if they don't want A, B, and C to match up with A prime, B prime, and C prime. So they're saying angle A should match up with angle A prime, B to B prime, and C to C prime. So what you should have done is you should have said, 8 compares to 12, 10.6 compares to 13.25, and 9 compares to 11.25. And then go ahead and see if those 3 ratios are not all equivalent. I think this one gives you about 0.71 repeating. This one gives you, I'm sorry, that's not correct. But 8 over 12, 10.6 over 13.2. If you grab your calculator, divide those out, they're not all the same. Okay. What I should have done with this question is eliminated these letters over here in this one. Okay, maybe gave them different numbers. And then what you want to do is say, okay, 8 is the small side over here, so small side over here is 11.25. So I'll take 8 and compare it to 11.25. Then I want to find the biggest side over here, which is 10.6, and compare it to the biggest side over here, which is 13.25. and then the middle side would be 9 and 12. I'll just take 9 and compare it to 12. And now when you reduce these, that becomes 0.711 repeating. This one here becomes 0.75, and this one's oh, sorry, that's 0.75, and this one becomes 0.8. And you reckon they're not all the same, okay? So they're not similar, not in the same proportion. That should have been the way I wrote the question. Some people had this, which they say, well, I'm following the A prime B, or A prime A, B prime B, C prime C idea that you told us in class, and that's great. Do that. And then some of us said, well, let's go small side to small side, larger side to larger side, and that's fine too. So either one of those was fine. I gave everybody credit because, I think I poorly wrote the question. I shouldn't have put those vertices in there or labeled them that way. Down here is 17. There's two ways of doing this one. You can leave it. I don't care if you left it in feet or if you put it in paces. It doesn't matter to me. I accepted both answers. Looking at these, though, what you need to do or recognize is that you have two similar triangles. You have this triangle here, which should be then similar to this triangle here. Okay. If I look at this triangle on the left, what do they say? The height of this is what we're looking for. We're looking for h. We can take what this total here is, what 138 plus 108 should be, that's going to be, make that one, do the math in my head real quick, make that a 110. So I'll get 246 paces. And this one over here is 3.5 paces. Okay, so I'm going to take 246 compares to 3.5 and set that equal to, now these two triangles are similar because that's a right angle there, and we talk about the shadows, how we can measure the shadows at the same time of the day, and the triangles that we get are going to be similar. So 246 paces compares to 3.5 paces, as h paces would compare to 2 paces for that height. Okay, so I compare shadow to shadow and then height to height. If you start to cross multiply, you're going to get, let me turn this ink off. Wait, 246 times 2, and then we would divide that by 3.5. And it gives you 100. I accepted 140.57 paces. That was fine. A lot of people had that. You then want to, if you put this in feet, you multiply it by 3, and you get 421 feet. Okay, or 421.7 feet. Be careful on how you left your. A lot of people put 140 feet or 421 paces. Make sure you pay attention to your units and your labeling when you're done with these things. Looking at number 18, there are a variety of ways to do the next couple. I'm going to do the way we talked about them in class, and the way the theorems that we talked about in class kind of helped you or were explained to you in the text. So if you remember, when we had a parallel line inside a triangle parallel to another side of the triangle, what we were allowed to do was say that this segment here compared to that segment should be equivalent to that segment there compared to that one. Okay, so I'm going to say 15 compares to x minus 15 as 20 compares to 8. Okay, so I'm going to get cross multiply, I get 15 times 8 is equal to 20x minus 20 times 15. So go ahead and multiply those out. 15 times 8 is 120. 20 times 15 is 300. Add 300 to both sides, you get 420 is equal to 20x. Divide by 20, x ends up being 21. Okay. Number 19, we learned in class that that segment compared to that one should be the same as this one to that one when we have three parallel lines cut by multiple transversals. So I'm going to say 21 over x plus 5 should equal 15 over x plus 3. Cross multiply, that's going to give you 21x plus 63 is equal to 15x plus 75. I'm going to go ahead and move my 15x over, so give me 6x over here. I'll subtract 63 from both sides, so it'll end up giving me 12 over here. Divide by 6, x ends up being 2. So that's 2. This question, if you remember, if we have an angle bisector inside a triangle, that angle bisector is going to cut these sides up, or this side over here that has a 42 and an x on it, it's going to cut it up so it's proportional. This distance here is going to be 42 minus x. That's that distance right there. So what I want to say is that that side, 42 minus x, compared to x, which is this part, okay, the core or the theorem said that the angle bisector divides that side, the opposite side, proportional to the other sides of the triangle. Okay, so 42 minus x, I compare that to that x. And now the 42 minus x, that came from this triangle here. So when I put a number over here, it better come from the same triangle, and the only number that comes from that red triangle would be 36. And then because x came from this triangle, okay, I better put a number down here that came from that triangle, so that's got to be 27. Cross multiply, I get 36x is equal to 1134 minus 27x. I'll add 27x to both sides and get 63x is equal to 1134. Divide by 63, x ends up being 18. So this here is 18. Moving on to the next one. Clear this. Again, we've got two triangles here that are similar. Come up with x and the scale factor. So I'm going to go ahead and say, that angle there is congruent to that one because of alternate interior angles, and then we've got those two angles congruent. I'm going to leave this triangle here on the left the same way, but I'm going to take this triangle on the right and redraw it so that's in the same orientation as the one on the left. So that's got to have one hash mark. That's got to be two hash marks. Okay, this triangle on the right is now this one down here. So the angle that had one hash mark was C, so that's got to be C right there. The one that had two was M, so that's M, and now that's B. So M to B, that was 12, and C to M, that was x plus 20. So now you can see that this side of 25 is going to match up to x plus 20. So those two need to be written as a ratio. 25 over x plus 20. And then the other side is this negative 3x corresponds to 12. So those are the two ratios you want to solve. I'm going to cross multiply. I'll get negative 3x squared minus 60x is equal to 300. Got an x squared, so you want to set everything equal to 0. So you get negative 3x squared minus 600, or 60x minus 300 is equal to 0. I'm going to divide everything by 3, so I get that, or negative 3 to get that to be a 1. So you get x squared plus 20x plus 100 is equal to 0. So now I get x plus 10, x plus 10 is equal to 0. So x is equal to negative 10. Okay? Put that in here, and now it asks for a scale factor. Well, if x is negative 10, that distance right there is going to be 30. So now I can compare that 30 to that 12. So 30 over 12, but we want to reduce that to 5 over 2. Okay, and that's going from the big triangle to the small triangle. If you wrote 2 over 5, that's going from the small triangle to the big triangle. Both those answers are acceptable. Number 22, again, similar triangles. Okay, that's the big triangle, and then I'll make this smaller one down here. The big triangle, we know that that's 60. Small triangle, we know that that's 40. Okay. The big triangle, that's going to be A right there. There's E, and there's B. If I travel down from E to B, I go 30 feet and then X feet. So that total should be 30 plus X. Um, and this here with the 40 is going to be X in that triangle. Okay. So now I can say 60 compares to 40. That's 30 plus X compares to X. Cross multiply, you end up getting X to be 60. Okay. I'm going to leave this last question up for you to do on your own, but the correct answers on this last one should be triangle ACD and triangle CBD. Okay. And remember, what you want to do is you want to take this triangle here and redraw it so that it is in the same orientation as that biggest triangle, and then make sure that the right angles match up, and in both those triangles, angle A should match up. Okay, and that will get you ACD. And then do the same thing for this triangle here compared to the overall triangle ABC, making sure that your right angles, and in this case angle B, match up, and that should give you CBD then. Okay, but redraw your pictures. It's the best way to do that question. If you have questions about anything on this test that you don't understand before the retake, make sure you come see me. Again, retake will be in the morning at 7:30.